I'm interested in this topic of how we actually do communicate. So Gabe mentioned earlier that he liked sitting in a room, not talking to anyone. I think most people do like talking to each other. Gabe's uncertain about this. But at the same time, there is this kind of trend in computing at the moment, right? So people were sitting at these desktops, and all of us have offices where there's desktops everywhere. But now everyone has these things, and Nathan mentioned most of us don't want to leave it from our site. I don't know if you've seen these videos of people taking your phone and dropping it, and people freak out because they think this is going to be the end of their life if they've lost their phone, right? But that also means that we spend most of our time not looking at the world around us. We're looking at our mobile phones. And I think that's something that needs to change. They're great devices, but actually as the world moves forward, we're going to have a completely different world where all of our devices are things we want to interact with. People talk about this thing called the Internet of Things. So this is a funny word, but what people are doing is taking all these devices that we have and trying to Internet enable them. So we've got cars. You're driving along. Now, I don't know how many of you tried to use your GPS while driving. I hope you haven't, because that's illegal. But the fact is, most of us are driving somewhere, and we actually want to tell the car where we want to go. We don't want to stop on the side of the road, fiddle with our system, and then carry on driving. We want to just carry on driving, talk to the car. But it's worse than just telling the system where you want to go. Sometimes we don't even know where we want to go ourselves, right? So you're driving along, and you actually realize, oh, I need a coffee. Now you want to have this conversation with your car. What are the options for coffee? There's Starbucks. Maybe you hate Starbucks. Maybe you love Starbucks. I don't know. So as you're driving, you want to have this conversation in many cases about what it is you want. Same thing, you're listening to music, etc. But it's not just cars. People talk about wearables. So you've got your watch. I don't know how many of you have tried to look at these very small devices or interact with them. It's a tiny screen, and actually most of them are designed more and more to have a voice interface. Smart homes, we're walking around at home. You don't want to have to go sit on the side of the wall. You want to find the movies you're watching. I hope you haven't had arguments too much about remote controls, but maybe in future that won't be something that has to happen anymore. Right, so there are endless reasons that we might want to talk to our machines. But I'm sure some of you have tried to use the technologies that's available, and it's quite disappointing, really. So if you've ever made a call to a call center, you'll probably have spent hours pressing all the buttons you can, saying all sorts of things, just desperate to speak to a human being. And that's really because of the way these things have been designed in the past. So there is technology to do this kind of voice interaction, but the state of the art is not really sufficient for us at the moment. And I believe that the reason for that is that historically people have tried to do this by handcrafting. And we know in all sorts of situations, handcrafting is just not going to cut it. People speak in all sorts of different ways. And if you try as an engineer to think of all the ways that someone might speak, you're just going to get yourself into trouble. The result of this also is that people don't also look at the understanding using handcrafting, but they also try to make the decisions based on special rules. So you take, I don't know, one of these old systems where you try to book a train. So you say, I want to go to London. System comes back, oh, you want to go to Luton. No, that's not what I said. OK, where do you want to go? I want to go to London. OK, you want to go to Luton. No, I just told you I don't want to do that, right? And why is it going around in this loop? I've told you, and you're very certain that I don't want to go to Luton. So we need this system which is tracking not only the understanding of what you've just said, but really the whole conversation. And that's very difficult to do in a handcrafted model. And so what we believe at VocalIQ is that the right way to do this is to use machine learning, and to use machine learning in a context that really works for dialogue. And I'm going to try to give you a few of the ideas that are underpinning our technology. So of course, I'm not allowed to tell you exactly what we're doing, but I'll show you some of the research that I did a few years ago, and some of the underlying ideas, if you like. So there are a few key components when you talk to a system. So first of all, you've got a speech recognizer, which tries to take what you've said and converts it into words. Next up, you've got to decide what those words mean, right? So let's take a running example. I want to watch a lighthearted movie tonight with Bill Murray, right? So we've worked out what the user wants to say. Speech recognition has come a huge way in the last few years, especially with deep learning methods. But now we have to also understand what this person meant. So in the context of a database, maybe you're Netflix or something like that, you want to work out that the person said lighthearted, but what they meant is that they want a comedy in our database. And they said with Bill Murray, what they meant is that there should be an actor called Bill Murray who's starring in this movie, right? So that's fine. But then you also have to now go further and look at what's happened so far in the conversation. Maybe they've repeated themselves, and actually your speech recognition is not very certain that this is what they've said, and maybe something else is more likely. So in what Stefan was talking about earlier, these stages are what we would consider the sort of state estimation part of the decision-making process. But then there is this decision about what are we going to say back, and that would be what he would consider the planning stage. And then we have to convey that to the user. So we have to decide how we phrase this, and then we have to use text-to-speech to send back the message to the person. And that would be the action taking. And really, the key idea for us is that everything needs to be learned automatically. We can't use machine learning for speech recognition, which we all now know works brilliantly. We can't just use it for text-to-speech generation, which we also now know works very well. If those are clearly working so well, why are we not using it for the rest of the system? And it's almost crazy that people are not using machine learning everywhere, because we know that machine learning is so consistently outperforming things long term. So I should say we're not the only people beginning to look at this, but most people are still really focusing on the understanding component and how we can use machine learning at that. And we really care about this whole conversation. I want to just give you a quick insight now into the understanding part and how context modeling and dialogue can really help that. So if you're like me, you're often looking for a bar, but did you actually mean you just want to buy a beer? Maybe you're speaking to your phone. Did you say a beer or a bar, right? They're quite acoustically similar. And actually, speech recognition is really good at giving you a distribution of what you might have meant. So here's our designer's crazy look into what this means. But there's some reasonably high probability you wanted beer, maybe some next estimate that you wanted a bar. OK, so now we basically don't know what the person wants. So we're going to say something like, hey, what did you say? And now we get some more speech recognition back. But the speech is really struggling at the moment because there's noise around. Maybe you're in a nightclub or something. And now we have to try and use both of these together to estimate what the person wants. But actually, the fact that we have recognition from before can really help you. So in this case, even though beer was more likely in the first turn, it didn't appear at all as an option for the second turn. And you can get a much better estimate if you take that into account. So actually, what the right thing to do now is to say that bar is really the most likely thing. That's just because it's the most likely given all the context of the dialogue. So this is something that underlies what we do, and something that we've pushed a lot in the research arena. So like many people, we're interested in using neural networks and have also tried all sorts of other architectures. And this is some results from a competition on how can we estimate what people want in a conversation. And actually, it turns out in this case, neural networks work really well, the best of the approaches that were tried in this particular competition. But I think the key idea actually is not necessarily what algorithm you do. The key idea is that you have to look at the whole conversation. It's not enough just to look at one thing at a time. So in the context of neural nets, you're talking about something that's recurrent and learns throughout the whole conversation. And that also enables you to learn much more about what people are talking about. OK, so that gives us an idea of how to do understanding. But how are we going to do decision making? So that's a very interesting question. And there's some really good mechanisms for doing that from the machine learning community. So people have talked already today about supervised and semi-supervised and unsupervised learning. And these are really great and actually are perfect for the understanding component I was talking about. In the case of supervised learning with understanding, you would tell the system, hey, lighthearted, that means a comedy. Bill Murray, that means actors, Bill Murray. Semi-supervised, you might tell them some of those, but then you might use a whole sort of assortment of other data to estimate what the person meant. But now when we come to deciding what we should say, it's not necessarily clear if there's a right answer, right? So you could say lots of things, and they all might make a sort of sense. But what really matters is what's the overall strategy, and how can we eventually get to something that solves what the person really wanted. If someone's struggling with their internet router, what are the right questions to ask them? Is it on? What's the strategy there? And that's where something like reinforcement learning, which is a third type of learning, really makes a huge difference. So I'm just going to try and give you a brief idea of how this works. So you're going to have an assortment of states where you might be in. And this is a very, very simple example of talking to a voicemail system. So we might be sure that you want to save the voicemail, which is on the left. We might be uncertain of what you want to do. And we might be pretty sure that you definitely want to delete your voicemail message. Then we can have three potential actions. So what I've shown here is a green action where you decide you're going to save the voicemail message, a blue one where you're going to delete the message, and a red one where you're going to ask the user, hey, what do you want to do? And then throughout your interactions with different users, you store an estimate of how good that action is. But it's not just how good it is in the context of one immediate step. So if you were only looking at what happened immediately, asking would be pointless, because you just ask and you're always going to not solve the person's problem, right? But if you can think of it in the context of the whole conversation, then you can get a much better estimate of the importance of that particular action. So you start with some estimates which are going to be pretty uncertain. But the thing is, you can then interact with the person and try out what actually you should do. So I'm going to see if this plays. We practiced before, so I'm hoping it's going to work now. So anyway, so you try out different strategies. You get new estimates because people behave differently. Sometimes different actions work well, sometimes they don't. But after you've done this for a long enough time, you're going to get really good estimates of what the best action is to take at any point. And then you have this kind of exploration-exploitation issue of how much do you explore and how much do you exploit along the way. So this is all very good if you have a finite state space. So that means you just only got a fixed number of positions where you could be. But what I said from the beginning is that we're never really sure what the speech recognizer is doing. And there's always some uncertainty about what people are talking about. So actually what you have in practice is not that you have three positions where you could be. You have some kind of probability. And so the usefulness of these different actions, what we call the rewards, that's really a function, and it's going to become a continuous function. But the algorithms then become still very much the same. So now we have this line, and we have three lines there. They're on top of each other, so you can't see the difference. But now what can happen is you talk, and as you now talk, you have to change your estimates of the whole line. And you can have some functional approximations to this. And again, much like a lot of machine learning at the moment, there's been big advances now that we can use neural networks as these function approximations. But fundamentally, the ideas are still the same. We're trying to estimate the importance of taking different actions. Now, for speaking to people, this actually is very, very helpful, because if you have these probabilities about what someone might have said, it's not very clear at what point you should believe what someone said, right? So if we get 67% chance that they want a comedy, is that enough to just offer them a comedy, or is that not enough? Should we now say, hey, did you want a comedy? Or should we just ask them again, I don't know what you're talking about? So that's problematic, right? But if you have this kind of structure, you can actually leave the system to learn what the exact optimal decision point is. And you can learn effectively that threshold in this simplified case. But it extends much further. You can actually learn what the best actions are at any point in time. So that's the essential idea behind what we've been doing for the last few years. And really what we've done is just take that and and put it into an API so that anyone can use. I'll just show you this graph. This is actually a system I was involved in a couple of years ago. And this system is actually speaking to real live people and seeing how it should interact, right? And so it starts, and it's very uncertain. That the green bars around the system are the uncertainty. And here it's basically has no idea what to do at the beginning. It's basically getting people very upset. So actually, interestingly, sometimes you have to do speech recognition tasks, and you ask people to transcribe things. And we have people saying, oh, you know, what do I do if there's profanity? So that's the profanity zone over there at the beginning. And anyway, that's kind of a side story. What happens eventually is that the system learns now how to react to all sorts of different cases. And actually, it eventually is pretty much as good as a system that's trained for a very long time. This system, the simulator trained one, is already much better than you would have got building up a system by hand. So it's maybe like 5% better in terms of its success rate, task completion rates. But if you get the system to learn by itself, actually speaking to people, then you get another 5% gain effectively. So it's really a big improvement over time. So what's the impact of all of this, right? So it doesn't mean we're going to have whole. Oh, I didn't realize it was a GIF as well. You know, are we going to have these systems taking over the world? So I think that's a question for maybe later today. I think people are going to be talking about that. But I think what's clear is that regardless of the device, as we go forward, we're going to have actually one unified interface. So whether we have a car, a wearable, a home, a robot, the thing that everyone knows how to do is to talk, right? So people don't want to have to learn these different interfaces for all these devices. And what you're going to have is, over time, there's going to be some system in the middle that looks at how we can talk to these different things. So our approach is to provide that technology so that it's easy for anyone to interact with. I think you've got a lot of people looking at how you can do things in this space. Of course, the big companies, Apple and Google, they care a lot about this as well, because if you're talking to all these devices, every time you want anything, they can scrape some ad revenue off of you. So if you want to know how to do that, just ask the previous speaker. So I think there are endless applications, but really the summary is that machine learning is going to be key to building these talking machines. And I'm not sure that everyone necessarily realizes how important it is to have a full conversation. And it's not just about understanding one sentence at a time. You really need to speak in a way that you can keep the conversation going. And I really think it'll completely change the way we live. You know, so Gabe said why he's excited about vision. I think this is really incredible, because it's going to achieve what we originally considered as being AI. If you look at things like the Turing test, it's about how do we talk to things. And talking is kind of key to what we consider to be intelligence. So this is a really great time for AI, I think, because we're starting to see the benefits in the context of these things we really consider to be key to human society. Thank you.
Do you have any questions from the floor? Tristan's got one. Oh, wait. Sorry, there's... Could we do...
Hi. So you're saying, you know, it'd be a unified UI, everybody can talk. Some people have a sign. Have you thought about that?
Some people have that?
Use sign language because they're deaf. So possibly you might even somebody who can't actually talk would need to sign. How would you deal with that?
So, so you'd use computer vision, exactly. So I think the fact is, even then, you need to have, effectively, you're still having dialogue, right? So whether the input is visual or speech-based, you have some indication of what the person wants, and you need to have the conversation. So early on, I had this wheel of these different parts of the system. And actually, what we care about is the conversation and how do we understand people. And it doesn't really matter to us whether you're speaking or signing. And in practice, just like Stefan was saying, we need to have multiple inputs, and I think all of them are going to become important. But it's also important to think about how we can consider the whole, everything together in this conversation that we're having with people.
Got one more question.
Hello. When you were explaining the decision component of how you select the optimal reward, I was curious about how you handle, in my imagination, a slightly harder problem, which is how do you handle the reasoning from a question to the options you can map to? For example, if someone says, I'm hungry, how do you figure out that they need a restaurant or to go to the store to get food? Or even something even higher level, like if they say, I want to make money or something, or I want to find a job. What are your limitations, right? Because it's pretty broad.
Yeah.
What kinds of things people can ask, and you need like some sort of reasoning system to solve that?
Yeah. So there are a few things. So there's firstly just what did someone mean by what they said? So that's what I was alluding to earlier before that decision-making part. And there's a lot of stuff that you can take from the community, things like word2vec, et cetera. And then there's another question, which is how do you do some kind of logical reasoning? And that's actually something that we're not super focused on as a company, but there are endless things you can do there as well. Stuff like probabilistic decision making, and all sorts of different techniques. But for us at the moment, it's not something we focused on heavily.
There's one last question here.
I think you're absolutely right that this kind of digital personal assistant is the next stage of AI. I think science fiction always produces great metaphors, and I think you'd be better off with the movie Her as a metaphor rather than 2001. Two questions. Firstly, you're competing with Google and Apple and Microsoft. How on earth are you going to do that? Secondly, what do you think these things are going to be called? I think we're going to need a generic name for them. Maybe if you're successful, they might all be called VocalIQs in the future, like a Hoover, but it's more likely there'll be a generic name like digital personal assistant or something. Do you have a theory about what they're going to be called?
Okay. So firstly, how do we compete with Google, Apple, Microsoft? So I think there are two things. So they have a different business model. So Google, Apple, Microsoft, they have Google Now, Siri, Cortana. So that's fine if you want to be locked into Google, Apple, and Microsoft. But there is a huge world of devices and other companies who care about also having this interaction with the system. And really, I believe that the right way to do this is to have something that's a bit more open. Well, I think probably both are going to be there. So you're going to have the big boys, if you like, doing this kind of specific virtual assistant. But I think you're also going to have these companies, probably not even just us, but that provide these services and technologies into the company. Then the second question, what are they going to be called? I really don't know. Possibly friends, right? So if you look at Her, like you say, boyfriends, girlfriends, and I think that's a philosophical question maybe of what does it mean to be a friend, to be not just assistant, but really someone that you can interact with. But I think that's probably quite a long way to go.
Awesome. Thanks so much.